So before moving on to this part, we actually have to see the example of how to find out the sum of n terms of an AP. But before moving on to the example, we first see what will be the formula for finding out the sum of n terms of an AP. So let's say sum of n terms of an AP is a plus d, in this way up to a plus n minus 2d plus a plus n minus 1 into d. So these are the sum of n terms of an AP. Now, so this will become our first equation, and the second equation we can write it as, we can write the sum of n terms of an AP in the reverse order. Like we first write the nth term of an AP, which is a plus n minus 1 into d, plus now the second last term, which is a plus n minus 2 into d, plus up to a plus d plus a, up to the first term of an AP. So once we have in the first equation we have written the sum of n terms of an AP like in the proper order, and the second equation we have written in the reverse order. So now we will add this two equation. So add first and second. Now when we add this equation, what we will get is twice of Sn, that is sum of n terms of an AP, is equal to, we have to actually add this first term of this first equation with the first term of the second equation, then the second term of this first equation with the second term of the second equation. So when we'll do this, what we'll get is 2a plus n minus 1 into d plus, now we add the second term of the first equation with the second term of the second equation. So what we'll get is 2a plus n minus 2 into d plus d. In the same way we have to do the procedure. So finally that we will get is twice of Sn is equal to 2a plus n minus 1 into d plus, as we have add the first second part of the first and second equation, what we got is a2a plus n minus 2 into d plus d. So in the same way we have to do up to the end. So after solving it, what we'll get is 2a plus n minus 1 d plus 2a plus n minus 2 into d plus d. So what will become n minus 1 into d. So the same term will get up to the n terms. So finally what we'll get is twice of Sn is equal to n into s2a plus n minus 1 d is repeated up to n times. So it will become n into 2a plus n minus 1 into d. So sum of n terms will become n by 2 into 2a plus n minus 1 into d. So in this way we can find out the sum of n terms of an AP by using this formula. So this is the formula for finding out the sum of n terms. We can also modify this formula as, like, sum of n terms we have seen is n by 2 2a plus n minus 1 into d. We can also modify it in the other form also, like n by 2. We can write 2a as a plus n minus 1 into d. So as you can see, a plus n minus 1 d is the nth term of an AP. That is the last term. So this formula will also become n by 2 a plus l. So l is actually the last term of an AP. So it means in an AP, if we know the last term of an AP, we can directly find out the sum of n terms of an AP using this formula. That is n by 2 into a plus l. A remains the same as the first term, and n is the total number of terms of which we have to find out the sum, and Sn is the sum of n terms. Now we see some example of this, so this formula will become more clear. So now let's take first example. Find the sum of 20 terms of an AP. Let's say AP is 1, 4, 7, 10 up to n. So we have to find out the sum of 20 terms of this AP. As we don't know the last term of an AP, so for finding out the sum, we'll use the normal formula, which is Sn is equal to n by 2 2a plus n minus 1 into d. So we have to actually find out the value of Sn. The value of n is 20 as it is given. Value of a, in this, a is the first term, so value of a will become 1, and value of d is the common difference. So as you can see that the common difference, there is a common difference of plus 3 between any two consecutive terms. So d will become plus 3. So now we can keep this value of n, a and d in this equation of finding out the sum of n terms, and then we'll get the value of Sn, that is equal to n by 2 is 20 by 2 2a, that is 1, plus n minus 1, that is 20 minus 1, 19 into d is plus 3. So it will become 20 divided by 2, it will become 10. So 2 into 1, that is 2, plus 19 into 3, it will become 57. So now we will solve it. 10 into 2 plus 57 will become 59. So answer we'll get is 590. 10 into 59, that is equal to 590. So this is the sum of the n terms of an AP. So in this way, by using the formula, we can find out the sum of n terms of an AP. Let's say one more example of finding out the sum. Say example 2, like find the sum of all 2-digit odd positive numbers. So in this we have to find out the sum of all 2-digit odd positive numbers. So as we can see, the 2-digit number starts from 10, but we have to find out the sum of odd positive numbers. So first odd positive, 2-digit odd positive number is 11. Next is 13. Next is 15 up to 99. So as you can see, there is a common difference of plus 2 between any two consecutive terms, and in this we know the last term of this AP. So we can use the formula for Sn is equal to n by 2 a plus l. So we can use this formula. We know the value of a, which is equal to 11. We know the value of l, which is equal to 99, but we don't know the value of n. So first we have to find out the value of n. So to finding out the value of n, we use the formula of finding the nth term of an AP, which was an is equal to a plus n minus 1 into d. As we know, an is the last term, so it is equal to 99. That is equal to a plus n minus 1d. A is 11 plus n minus 1 into d, which is equal to plus 2. So 99, we will take this 11 to the next other side of the equation. We'll get is 99 minus 11 is equal to twice of n minus 1. So 99 minus 11 will become 88 is equal to twice of n minus 1. So 88 divided by 2 is equal to n minus 1. So now when we solve it, we will get as 44 is equal to n minus 1. So value of n will get as 44 plus 1, that is equal to 45. So now we have find out the value of n. Now we will keep the value of n in the equation, which is Sn is equal to n by 2 a plus l, and now we will find out the sum of n terms, that is n by 2 is 45 divided by 2 into a plus l. A is, as we have seen, a is 11 plus l is 99. So now when you have to solve it, so 45 by 2 into 11 plus 99 will become 110. So that is equal to 45 into Now we cancel this 110 by 2. So 2 divided, so 110 divided by 2 we will get is 55. So 45 into 55. So value of 45 into 55 is 2475. So when we solve this value, 45 into 50, we will get the value as 2475, which will actually give you the sum of all two-digit odd positive numbers, which is equal to 2475.